Hello, let us start with chapter 9. So the question here is a steel wire of length 4.7 meter and cross-sectional area 3 into 10 to the power minus 5 meter square stretches by the same amount as a copper wire of length 3.5 meter and cross-sectional area of 4 into 10 to the power minus 5 meter square under a given load. What is the ratio of Young's modulus of steel to that of copper? Let the Young's modulus of steel and copper be Ys and Yc respectively. Length of the steel wire is given as 4.7 meter and length of the copper wire is 4.7 meter. And the cross-sectional area of steel wire also is given, which is 3 into 10 to the power minus 5 meter square, and the cross-sectional area of the copper wire, which is denoted by AC, is 4 into 10 to the power minus 5 meter square. Now let the load and the change in the length be F and delta small l respectively. So the Young's modulus will be equal to FL divided by A into delta small l. That means A by delta small l equals AY divided by L. Since F and delta L is same for both wires, we have AS YS divided by LS equals AC YC divided by LC. So eventually it comes out to be YS divided by YC equals AC into LS divided by AS into LC. So putting in the values of AC, LS, AS and LC, we get 1.79. So the ratio of Young's modulus of steel to that of copper is 1.79.